Cool. So hi everyone, and welcome to the ninth Local Stack community event. It is always great to see everyone gathered here today, eager to just explore some of the new open source projects in development and how you can build your cloud applications and your cloud infrastructure in a more seamless manner. So before we move further, let me highlight that this particular community event will be recorded and it will be later uploaded to our YouTube channel. If you have not subscribed to our YouTube channel yet, now is a pretty good time to do so. Coming up next, we have the agenda. It's pretty short. It's pretty simple. At first, we are going to have a pretty short intro and welcome. I will be introducing all the speakers right over here and the topics that they would be presenting today. And after that, there will be two rapid sessions. This would include like some technical presentations, some demos, and how you can overall use these projects for improving your cloud development workflow overall, and how you can basically leverage these projects and even contribute to them. And finally, I will be speaking a few things about LocalStack 2.1 because we released out a new minor release the last week itself. So I just want to highlight a few of the new features and the new enhancements that we have released. And finally, we can jump over to the Q&A part where you can ask all your questions about LocalStack, about FABR, about GDC, and rest of the things that we are pretty much working upon. So without spending much of your time, let us directly jump into the intro and welcome. So today we have two open source projects that will be taking the entire spotlight. The first is the all-new modularized component-based infrastructure as code framework called OpenFABR Cloud Development Framework, and this will be presented by Janaka. Janaka is the Chief Product and Technology Officer at FABR, and we did have had a lot of conversations with Janaka like almost a few weeks back, and he has a lot of like in-depth knowledge about ISE infrastructure ecosystem and how FABR is kind of building upon to that. Next up, we have Chad and Paul, and they will be introducing us to the exciting solution called the generic development container. The one thing that basically caught my eye about generic development container was over the community Slack itself, because there was this one user who was having a lot of trouble with using localstack on Windows, and they introduced their project that they are using to develop applications using localstack on Windows itself, and it is pretty exciting to say at the very best. I have not explored both of these projects, to be pretty honest, and I just know about them at a pretty high level, but they look super, super awesome. And I guess Chad, Paul, and Janaka will be taking us into depth regarding all of these. So just as a point here, we will be using something that's called as Slido for our Q&A part. You can even use Google Meet chat. You can maybe unmute yourself and you can directly speak up if you want to ask your question. But please do so at the appropriate time when the speakers are ready to answer all your questions. If you have an urgent question that's coming up, please put it up on Slido itself. You can go to slido.com and you can enter this one particular link. Sorry, this one particular code, 3771095. I can even share the link right over here so that everyone can join the Slido link, and you can just keep a tab open on your browser or whatever you're using to join this meetup. And you can pretty much put all your questions in, and all the speakers can take them up once their sessions are over. And with that said, I guess I can hand over the stage to Janaka, who will be presenting the first session on how you can leverage OpenFABR Cloud Development Framework so that you can start developing your cloud infrastructure in a fast and seamless manner. So over to you, Janaka. The stage is all yours.
Cool. Thank you, Harsh. All right, let's get a old screen share going. Right, I guess we've covered intros already, so I'll skip that. I have a little bit of icebreaker here. We're chatting where I'm at the moment. I'm based out of London in a place called Isle of Dogs, historically called that. These days it's called Canary Wharf. Some interesting pictures how the area has changed over the last 50 or 60 years. Right, so you're not here to talk about London. We're here to talk about other things. So I'm going to start off by setting a little bit of context, what sort of FABR is all about, then lead into OpenFABR CDF, and we'll dive into kind of some of the details and then how local stack kind of comes into the picture. Cool. So FABR is our vision is about making an app store for cloud infrastructure, really, and we want to kind of make cloud infra delivery faster. We want to do this through modularization and customization, and we're doing it using an open source foundation. Why are we doing this? Because quite frankly, cloud infrastructure development is slow, it's bespoke, it's error prone. And this is kind of partly where LocalStack helps us out. Like I said, there's kind of three pieces to this. A modularization system, which is OpenFABR CDF, that we use to build these packages called Lego sets. And then on the commercial side, we have this UI that helps bring all this together in an easier way. So I'll start off with a good old stack kind of diagram. Can't have a tech presentation without one of these. So all the way at the bottom, as you would expect, we have the cloud vendors, AWS, GCP, etc. On top of that, we're built using CDKs, so AWS CDK for Terraform or Pulumi. And on top of that, we've got the Cloud Development Framework. So this is kind of the rules of how we're going to go and develop infrastructure. Then we use CDF to create these packages, which are like the brain. This is where most of the action happens. It's sort of like the business logic of infrastructure that we're building. And this is the main area where LocalStack comes into the picture. Then there's, as you would expect, if you're familiar with the sort of CDK kind of world, you have a ISC application project. So this is either a AWS CDK specific, CDK for Terraform or Pulumi specific project that pulls all of the pieces together for execution. And then finally, the UI that kind of makes this even easier, allowing you to kind of edit the configuration and then do the orchestration to deploy. UI looks a bit like that to help you visualize this. The OpenFABR framework is the thing that allows us to kind of build tooling on top of these packages and deal with the orchestration. So the things to remember, the CDKs are kind of like the bridge to the cloud. CDF, the Cloud Development Framework, is those are the rules. We use those rules to build packages, which are kind of the brains. The IAC application project is kind of the glue, and then the UI is like even more glue to make it easier. Cool. So let's dive in a bit deeper here. I forgot to start the timer, so I have no idea how much time I've spent. Cool. So the Cloud Development Framework, the rules. So this is like a really lightweight in a way system. It doesn't have any cloud-specific logic there. It is sort of cloud aware in the sense that it understands the vendors that it supports and the ISC runtimes, etc. But it's mainly the system and rules for doing the modularization and customization. So then as I covered, we use the CDF to build these packages, the brains. Think of these as like Lego sets. So these Lego sets have kind of three things that the CDF kind of enforce and for runtime purposes that you kind of got to decide which cloud provider, it's bound to which ISC runtimes. Is it CDK, TF? Is it AWS CDK or is it Pulumi? And which programming language? Then there are four kind of interfaces that a package conforms to, which is defined in the Cloud Development Framework: service, components, network, and relationships. So services are essentially your application code targets. So that could be Lambda, it could be ECS Fargate, etc. In the AWS world. If it was Azure or GCP, you would have similar equivalents. And then components are other cloud building blocks, so like databases, specifically like a relational database like AWS Aurora. Networking maps to a VPC typically, and then relationships is the rules and policies that allow these pieces to talk to each other. So what does one of these packages look like? So I'm not going to do like live code demos and stuff like that because I thought might not have enough time, things might go wrong. So I've just done a bunch of screenshots to kind of go through this stuff. So, sorry, going back one slide. So here's a package. It has these like 4 concepts, and you essentially go and write code to implement these different building blocks. So an example here of us going and building a service that is implementing ECS Fargate in the backend. On the right-hand side here, you can see how we are using this type system to be able to pick the types that are defined against the configuration to go and make decisions on which pieces of infrastructure we're going to build. So this particular package is designed to say we have a container environment and we're going to use ECS. And you could see that in the config here, type and subtype. So you have container and ECS, and from here you can kind of pick those pieces up. And then within details, you have more parameters that you can program against. And here we have an application type called public, and you can see how here we are picking up the fact that the configuration has something called public, and then it's going to run the code to go and build out a service on Fargate. And again, here task is another type that you can specify, and then it goes and has some other logic to go and build different pieces of infrastructure for that. This configuration file is how a user of a package will interact with the package. So you're essentially saying, as you can probably guess, hopefully it's intuitive enough. I want to run a container in an ECS Fargate backed environment. There's a few parameters here I give to keep it really simple, and away you go. So how does this come together in a project? So there are a few concepts here that come together. So we have a config file that we've seen already that provides the parameters. There's the particular Lego set that you're going to use that goes along with that configuration file. And then we'll dive into this in a minute, custom modules. So you have the ability to go and customize the infrastructure as a user of a package. And this also comes together in an IAC application project that you would execute using standard kind of tools. So this is what the entry point would look like for a project. Here you can see how we're loading up that config file that you saw earlier on. We're referencing the particular package that we want to use. And then here we're using the Cloud Development Framework kind of factory to glue it all together. So you take the config file, any custom modules, which I'll show you in a second. And then you do in the case, this is an AWS CDK example. So you would do a CDK deploy to kind of execute this. Or if you're using the UI, you can click a button in the UI to kind of do the same thing. Custom modules. So custom module, I'll go back one step again just to point out. So custom modules is a code file that's referenced here, and that code file looks like this. So it's like inversion of control. So in this this overload, you have access to the entire stack that's created. So all the infrastructure that's been defined, you have all the the instance DOM, if you like, and you could go and pick out one of the pieces of instances of infrastructure. So in this case, I'm going and getting the cluster, and I'm going and adding a cloud map namespace to it. So in this way, a user of a package could, at consumption time, go and make certain customizations if the packaging itself doesn't do everything that they need to. So how do we kind of use LocalStack in all of this? So in that package development, test and development loop is really where LocalStack comes in. As you would expect, you write some stuff, it doesn't work off the bat. So you've got to go and run it against something to see if it works. Now, if you're doing this against live cloud, as you'll probably appreciate, some pieces of infrastructure take tens of minutes. Like a database could take 15 minutes to spin up. So if you're trying to iterate through creating a package and test it, that's going to take a really long time to get that feedback loop if it goes wrong. So we use LocalStack instead, which gives us a much quicker feedback loop to run through. which I think is a bit different from how a lot of people use local stack. As I understand, people tend to kind of use it to locally kind of emulate the cloud and run your application tests against. We're using it to test and develop infrastructure itself. So a little bit about how we use local stack, if interesting. So I tend to personally start local stack up like this, passing API key here, persistence set to nothing. I switch on all the debug and tracing, which I've found like makes it easy when things go wrong. I get the extra kind of log information and stuff like that. And then this is how I, during development, kind of execute the project, do a bootstrap, and then a deploy using the CDK local wrapper provided by localstack. And these profiles really make it easy to kind of switch between running the stack against localstack or running it against the real cloud. And if you're interested, this is kind of how I've got the credentials, the profile configured up. Yeah, so like I said, the benefits of us using localstack with package development is it makes it way faster to go through that loop. Unit tests aren't a great fit for the initial development because if you kind of don't know what the infrastructure is going to look like, the unit testing frameworks and assertions become a bit difficult. And saving dollars because slow running infrastructure, you can't keep like kind of tearing it down. When you're developing, you kind of a database, you end up leaving it up there, and it kind of costs you could cost you a lot of money. So there's speed improvement and that, and I think it's more environmentally friendly, maybe. In the future, we probably will start using localstack for doing more like package integration testing. So does the package let the application kind of work the way it should do, like two pieces of the application talking to each other, that sort of stuff. So that's all I have. We're trying to make Big Cloud simpler. There's some links here for our kind of GitHub repos and the documentation. Please give us a star. Get in touch if you have any questions offline. Yeah, shall we doing questions now or later on?
I guess we can do questions right now. I guess we do have a few questions that are coming up.
Oh, cool.
Yeah. Cool. So let me just share the links right over here.
Really helpful.
Yeah. So this is a CDF repository. So please drop in a star over here so that you can get to notice like the recent developments of the project. And there is a talk site which can answer most of the technical queries that you might have. So Janaka, if I can share my screen, maybe I can just walk through.
Yep.
Like, we have got over 3 questions right now, I guess. So maybe you can enlighten us with like, how's the whole state like over into this part? So the first question is like, how does managing state look like in FABR? Yeah.
Yeah, so I presume you're talking about the state of infrastructure in itself. So we offload that to the CDK, loosely speaking, layer. So AWS CDK, CDK-TF, and Pulumi are the 3 we support. We're just using their state management engine. Does that answer the question? I don't know who asked the.
Yeah. Unfortunately, it's anonymous.
Yeah.
Yeah.
I guess there's a little bit of state that we through like the commercial product that we manage, which is to do with, you know, when you've run a configuration, is that infrastructure there or not? Whereas if you're running that kind of on the command line, which you can do, you don't need to use the UI. You can take, as you probably guessed, that project and just do a CDK deploy. You don't kind of get that track history of kind of overview of what infrastructure you have up and running and what you don't.
That makes sense. I guess we have another question, like, do FABR work with any unit testing framework? Any examples?
Yeah, so if you go and have a look at the CDF repo, there's a samples project for packages and projects. And if you look in those, you'll see there are some unit tests. So again, the framework in itself at the moment doesn't add anything special for unit testing. It's what the unit testing framework for the language you pick. Today, CDF only supports TypeScript, but in theory, given the CDKs support multiple languages, we can do so. That's the first thing, and then how the assertions work is down to whether it's AWS CDK or CDKTF or Pulumi. They have slightly different flavors of how that happens.
Yep, that makes sense. Thanks a lot. And the final question is like, how stable is FABR right now? Are there adopters yet?
Yeah, so we're really early days. We've been around for about 6 months.
Wow.
So not that long. I wouldn't say it's as a framework project. In its early days, we haven't had a ton of feedback. Yeah, we don't have any adopters at the moment doing anything like in production or anything like that. We've got some people playing around with it and experimenting. We've also been experimenting creating packages for open source projects. So yeah, hopefully that answers that question.
Yeah, definitely. I guess we would be more than happy to explore some of the examples within LocalStack itself. Like we have this new developer hub, so we are trying to build on CDK itself. So maybe trying to adopt FABR and see how it works out. I guess it would be pretty great. So with that said, I guess we are done over here. So thanks a lot, Janaka, for introducing about FABR right over here. And it was a fantastic presentation. And we'll be more than happy to see like how this whole framework grows and how it is being adopted by the community right here. And with that said, I guess I can pass over the mic to Chad and Paul to basically talk about generic development container. And yeah, I guess the stage is all yours, Chad and Paul. Please go ahead.
Hey, I'm Chad. That's pretty much the intro. I've been using LocalStack for about 7 years. The same amount of time I've been working on AWS. And I created a Visual Studio container that Paul and I were using for a while, but Paul doesn't like Visual Studio. Well, let me rephrase that. He wanted to use a different IDE. And so he took the monumental effort to port that container into something much bigger that is the GDC that we've been using for quite a while now. So I'll let Paul give his intro and go through some of the GDC, and then we'll switch back to me and I'll give a demo.
Hi, I'm Paul. I'm a full stack engineer and a principal solutions architect. The dev container concept was great, loved it, just was not a fan of the IDE. So I decided to make something that will work with any IDE or no IDE at all. If you just want to fire up Vim, in a shell and get your code on and deploy, then you're good to go. So let me share my README here. So this is the generic development container repository and the primary README. Pretty much it only depends on having bash, so you can use git bash on Windows or regular bash on any Nix type system. Works great in Mac. Runs on M1 architectures as well, not just Intel. And it does not do Docker inside of Docker. It does sort of Docker next to Docker. So all the containers run side by side, and they're all connected via what we call the DevNet to allow them all to communicate with one another. And so this allows you to potentially have multiple projects that have dependencies on one another, and you can bring up a local stack container and deploy from all different projects to a single local stack container, but then have them all communicating on a Docker network amongst themselves. And then you have the options of exposing ports to the host, or you can keep it totally internally to the container system itself. We at my company use this in our CI/CD pipelines as well. It is extremely customizable for any language, really, and it doesn't necessarily have to be for cloud deployment. It supports numerous languages: Python, PHP, .NET, Java, TypeScript, whatever you want. And let me get down here. Basically, it's all CLI driven. You just run the dev container script in the repository folder, and it'll fire it up. There's tons of command line options, and especially environment variables, and they're all outlined as to what they do and the defaults. And I know it seems kind of overwhelming. For the most part, the defaults work great. It's all very customizable with custom config files. You can set up a global custom config file, a project-specific config file, and it kind of reads them in from the global, and then you can override more and more specifically depending on whatever custom needs your project has. And LocalStack was huge for the cloud-based deployment. We use a lot of Pulumi for our infrastructure, and being able to fire that up and rapidly iterate was really huge. We even created a mock authorization container that fully supports OAuth. So if you want to develop, say, an SPA application, you could forward the port to the host and then connect from your local machine's browser to the application running in the container, and then authenticate against this mock container for the authentication, and get your JWT token, and then use that against authorizers in the AWS or LocalStack environment. So it fully supports end-to-end development, as well as testing. We just recently added a README to the repository for how to use Cypress testing for fully automated front-end, end-to-end testing. We do most of our Python, or most of our Lambdas are Python based. So we have, PyTest related READMEs, and there's a bunch of quality of life workflow enhancements in there. I'm not sponsored by Bitwarden, but I do use Bitwarden for a lot of enhanced workflows in terms of being able to get the MFA tokens programmatically from my vault, so that I can do multi-factor authentication to AWS to do my deployments all via CLI without having to pull out Authy or whatever phone app, and various things like that. There's a ton of different READMEs in there that are sort of linked to from the main README for just different quality of life enhancements. And it is fully open source, and we welcome any contributions to the project. And it gives you some additional examples here of how you can create SSH jump tunnels using SSM to securely access hosts within private VPCs and AWS, or forward ports to databases. And it's like I said, it's quite extensive and would require way more time than we have here to go much deeper into. But what I will do is kick it back over to Chad, and he can give you a real-time example of kind of how the GDC can do everything end-to-end using LocalStack for a full cloud application. Back to you, Chad.
Awesome. Yeah, everything Paul just said, all those features, we use all those, especially the secure SSM into private resources. That's just been sweet. I'm going to share my screen. I wish I had a multi-project demo to show now. This is just a single project, but it's still pretty cool. So you can see my screen now. Thank you. So I'm sitting in this project right here. It's a public project. Let me get to the top real quick. This is the README. This is what we're going to show using the GDC and localstack locally. And I'll briefly cover how to deploy to AWS. I didn't set up my credentials for this project. It's trivial though. The project itself is an end-to-end solution. It includes VPC, public-private subnets, RDS, DynamoDB. This project isn't using RDS, but I took it from another project that we're doing that does, but I left it in there just for to make it so others could potentially utilize it. We have a Vue front end and API gateway for REST and WebSockets, a few Lambdas, S3, we store files in S3. The whole project itself is just storing S3 files and being able to tag them. And yeah, that covers the project. We use Pulumi to do all this for the IAC. Here are the pics of the UI. I'll kind of go through those quickly. Well, let me cover this one just a little bit more. So the UI itself in this demo app is separated from a public side and a protected side. And we use this blueprint a lot because that way you can implement a whole public side app and then allow users to sign in and then just switch to a sub URI. Here's the auth0 mock that we'll see. The configuration itself sets up some users, and then it goes ahead and defaults some user login for you. The app has some pretty extensive fonts and colors and X components that Xander created. He couldn't be here. He had a different appointment, but we'll cover that real quick. And then the main functionality is here where we're going to do the upload and the tagging. Go down further, get done with UI. We already saw this slide. That's about the dev container. So I wanted to re-put it in this project so that would bind together the GDC with localstack, with Pulumi, with the solution that we're building. This project exposes a couple of known issues. One we're going to see right off the bat, and that's the first message that comes from the WebSocket server. Even though the Lambda says it's sending 309 bytes, it's empty, and that's going to cause our test to fail the first time, but subsequent runs work just fine. So the quick setup, like Paul was saying, going through the myriad of env options that you can set in the GDC, as you'll see, it's pretty straightforward to go through these steps and be up and running in just after cloning the repo. So we'll go ahead and do that right now. You can see that I'm sitting on main in this repo. I don't have any changes. So sitting in that root directory, when you look at that, where I put my localstack pro key is in the env GDC local. That's the only addition I've made to this repo after cloning it. So the env GDC itself, we're saying, yes, use localstack, give the GDC a name, use localstack version 2.1.0, use the auth0 mock, and we set up some other things for the mock for default user and password. This is how it auto fills that in. We set the localstack endpoint, and we set the devnet because we're going to share the network across the containers. So I'm sitting in the root of the directory, and I'm going to run the dev container shell, which is going to start the GDC. I have no containers running now. They're coming up. And they're all up. And the output shows you how to get into the dev container for the GDC. It just started up the auth0 mock. So we're going to get into the dev container for the GDC. At this point in time, our solution is not deployed. So it's a pretty big solution the way we generally structure these. I'll show the IAC directory real quick. So we have this top level. That would typically be in another project. That's the top level that's setting up our VPC and some security groups, things that are at Route 53, things that are at a global level in AWS. And the way we've done it to set up global networks is we have a whole separate project for that. And then we import the stack references from Pulumi into these. So we have the top level, we have the database, and then we have, excuse me, the LSGC, which is the actual solution we're trying to get to. And then there's another, these are all separate pipelines. So we have another pipeline that's a jump host that'll deploy a host with no open inbound ports that's SSM enabled into a private subnet that the scripts using SSM from the GDC will allow you to open a shell onto, which is pretty awesome. So this will just take a minute here. So make local top, so use a little bit of make instrumentation in here to just to simplify things. So to create an environment, we're using these, gosh, what do they call them? Path specific environment variables. So if the make target starts with this and can have anything else after it, then all these environment variables will get set. So that's how we configure an environment for local, for us, which means on our laptop with local stack. Non here is non-production, and I've stubbed out where you would put a couple of things to make this work. And the targets are the same. You know, the only thing you change would be the local to non. Assume some AWS credentials first. Whoops. So I'll go ahead and run the top level pipeline. There's a single target that does all this, but I'll just go ahead and do them separately really quick. So top level, these are generally all structured the same. We're going to have an index at the root for any kind of blueprint we put out there. And we include in dependency order the different things we want to create. So CloudFront logs bucket, that I separated that out into the top level because I want that bucket to be there. I don't want it part of my CloudFront distro because then I can't destroy the distro because there's stuff in the bucket. So I just leave the logs in there. That's why that one in particular is here. We create a VPC. There's some account specific configuration we have to create also. And then we're setting up Route 53 domains for the solution. Come on, where is it? There's the database. So I also put, this solution is using an adjacency model, DynamoDB NoSQL configuration, where we're having items put in the database for a user as an individual row. And then with the adjacency matrix, we use an ID and a range key and other items for the user, like S3 object uploads, or they could be anything really that you wanted to attach to a user, or some other type of solution, like we did this for a finance solution for invoicing, where invoice was an individual line item, and then, or an individual row in the database, and then the line items were also. So that created already, and I think that's, oh yeah, I have the RDS commented out, so this will go an extra 2 minutes faster. GDC, deploy that. So that did a pre-build for all the Lambdas. They're already built, so that's pretty quick. Now for that deployment, so as you can see up here, this is the GDC running, And all the local stack log is coming out here, as you're familiar with Docker Desktop. And you can go in here and see the local stack log at the same time, which is how I figured out that that first WebSocket message coming back was empty, which we'll see in just a second, that I've been talking to Harsh about. Thank you so much. Okay, just takes another few seconds. Let's go back to that really quick. Right, so this whole section here minus the DynamoDB, this is what we're deploying now. And it's almost done with the Lambda functions. Gotta hit the API gateway. So the user interfaces, I'm a big fan of WebSockets, so I included that in this demo, which complicates the unit tests because the way some of the use cases work that we'll see in the test, they're async. So we're gonna upload a file and that's all done. So we're gonna upload a file, but the file itself landing in S3 in localstack doesn't represent the file in the system for us. That's its DynamoDB entry. But the thing that creates the DynamoDB entry is a trigger on object created in S3 that fires a Lambda that creates a DynamoDB entry. That DynamoDB entry, there's a DynamoDB stream, which is firing a Lambda, which is looking up connected clients for objects that are created for that user and for events that they're interested in, sends them a WebSocket message. That was pretty quick, I know. We'll go back through it in a unit test right now. So local LSGDC test. So we're using PyTest. And there's a simple target. Like I said, all of these, anything starting with local LSGDC is picking up all of these environment variables, and then it's going to run test and pick that up out of the application make file. So we're going to, the reason why I want all of those environment variables is because before the test starts, we're going to do a Pulumi stack output for the LSGDC stack, and we're going to save all of that output because the tests are going to use them for the endpoints to hit the REST endpoints, connect to the WebSocket, connect to the database, do anything they want. Now, these are black box integration tests. They're being written with a unit testing framework, but the focus here is to create an integration test that is proving that the system is going to work from how it's being hit when it's put into AWS. How is the UI going to hit the back end? It's hitting the REST endpoints, and then there are going to be side effects and things that are going to happen. So that's the sort of test that we're writing here. So the first time we run it, and I have a timer, the tests are async, like I said before. I have a timer, so this first run is gonna take a minute, actually, because it's gonna wait for the timer to time out. You see there's a lot of things happening in localstack. See this right here? That's our first WebSocket message coming back. It's a WebSocket message that a new file has been uploaded. Look at the DynamoDB stream, you can see where it's sent. It says the size of the message here somewhere. I'm just buying time, waiting for it to time out now. But if it times out too quickly, it's going to scroll really far. All right, it's almost there. Connection with data, sending. So it says it's sending this, right? Insert S3 item, whatever, but we got this empty message. This, like I was explaining to Harsh, so now it finally timed out with the timer in there. That only happens for the very first WebSocket message. It's really weird. I've noted it in the README. So all the tests are running. They're going to get to the end in just a second. So the tests are in this auto test directory. There's only one file. If you're familiar with PyTest, see, so 1 failed, 2 passed. Now we have all these endpoints are all protected by authorizers. So we got a bunch of authorizers running, and we uploaded files, and lambdas were triggered based on the files landing in S3, and all kinds of stuff happened for the system, right? And the tests are asserting that those things happen correctly. We'll run it again. Be much quicker. We won't have to wait that extra minute. So I'll let that finish really quick before I go on. So they all 3 passed. Yay! I love tests. So if you're familiar with PyTest, we got this auto use true PyTest fixture, which a lot of times is called a runaround test. So this for us lets us create a section here before a yield. This is going to run before every test. Then it's going to yield and the test runs. And this is going to run after every test. So to make them very explicit, each time the test runs, like I'm going to log in and get a JWT to use against the authorizer. This is hitting the auth0 mock. I'm going to save that principal ID, and I'm going to connect the async WebSocket client that I wrote. That's a utility in this project. And then after the test, we're going to log out, and then we're going to clear some S3 resources and clear some DynamoDB resources and close WebSocket connection and whatnot. Now, here's another side effect of an async system. When we clear the user DynamoDB items, what's happening? That DynamoDB stream handler is sending WebSocket messages at the end. Well, the amount of time it takes for it to send the messages, this to end, and the next test to start is not enough time for those messages to go nowhere. This test starts, and it creates a WebSocket client, and it subscribes to messages, and it gets messages that are unintended for it. So when we get to a test where that matters in the callback, that's why it's documented in here. It's like, hey, did we get the item that we're looking for? If not, we're just going to log, hey, that's not, we don't care about that one. We're waiting on a different item with a different range key. And then anyways, we use, I won't go through the whole test, how the async breaks out. But we use events to synchronize some of the processing. It's like, we want to wait until after an S3 item is inserted before we start hitting some REST calls to do some assertions on it. So that's how these tests break out. And then we modify tags in another test to prove that modifying tags works. And I just set it to my name. And then this portion actually runs a test. So that's cool. We can sit here and run the test over and over and over. And we can also, of course, there's a make target for LSGC, run the user interface. You guys can still hear me, right? Sometimes my mic cuts out, and when I'm not looking at the screen, I'll talk for 5 minutes and I don't know. Okay. All right, a couple more minutes. All right, I'm running the UI for that whole thing. We proved that our REST calls are going to work, that our WebSocket calls are going to work. All right, so we can launch the UI, and now we can be confident. Let's assume that for this solution, I wrote 20 more tests that prove that the whole thing works. We deploy it. Here's the auth0 mock. Oh, it's got some different things that happen in it. Thanks to Peter. And we get logged in, open the inspector. So we can see everything that's happening. So it's pretty stubbed out. Right, you know, there's a few things that I took from some other projects, but like these aren't doing anything. This logout doesn't do anything. This one does. All right, you log out there, come back here. Whoops, that was right click. Anyway, so we want to get to the S3 store and we want to add some files. Adding the files, so the standard design pattern most everybody's probably seen. All right, the UI is going to hit the REST endpoint on the back end and ask a Lambda to generate pre-signed put URLs. That Lambda has permission to do only one thing, and that is assume a role. And that role it assumes is the role it's going to assume to generate the put URLs to return to the UI client with that encoded pre-signed URL, because the client is going to run as that role to do the put. So you have to assume the role first to create the URLs to return. Then it's going to upload the files. Let's get a couple files here and drop them in. The files are uploaded that quickly to local stack in S3. The create object event is fired. The Lambda fires. It looks up the metadata on the S3 object, creates the rows in DynamoDB. The DynamoDB stream handler fires a Lambda and says, hey, and so since we're using auth on all of these objects are only being created for me. So when this is deployed to AWS, that would be individualized. So my connection is stored as me with my principal ID going through the auth0 mock, and it sends WebSocket messages that you can see right here. It's, hey, there's some inserted S3 item. There's two of them. And when these come in as WebSocket messages, that's how you saw the dynamic UI update. Same for delete. So we got the remove S3 item. And since we ran the test first, this just boggled me for so long. Since we ran the test first, we got past that initial startup hurdle of that very first one message being empty. And so my first upload didn't fail because we're beyond that, which is great, as long as we document it. That is the demo. There is a lot more in here that you could go through. This authorizer is the same authorizer that's used in AWS or locally. There's common layer, and then these are the rest of the Lambdas. Yeah, there's one setup piece I skipped, which is running a make target to create a virtual ENV. So I'm running on a Mac M2. I'll mention that, so this is in the GDC, in the dev container, right? It needs one virtual environment. Well, my IDE running on my laptop needs a virtual ENV. It's for my laptop for all the autocomplete and everything to work. That's why there's two there. And that, I think is pretty much it for the demo, don't you, Paul?
Yeah, I think that covers the testing on the back end and the browser on the front end.
Awesome.
And I left 3 minutes for questions.
Yeah. We actually have a lot of questions, so let me maybe share my screen and I can just go through some of them. Cool. I hope the screen should be visible.
Yeah.
The very first question is like, any reason for not having Terraform or CDK? I guess this was one of the questions that flashed my mind when I initially read like GDC's README.
Yes. So when I worked at NOAA, National Oceanic Atmospheric Association, we did a study when we were working with NASA, and we were doing an IAC study, and some guy said, hey, I want to use a real language. This was before Terraform had a CDK. And so he's like, let's try Pulumi. And I was Mr. Terraform coming from Nike, and I'm like, no, we're not doing that. He's like, yes, you have to do it for a day at least. And we did it. And we're like, oh man, we're not going back. So to have autocomplete working in your IDE, that's why. So if you look at the timeline of Pulumi, And when Terraform created their CDK and when AWS created their CDK, you know, it's after Pulumi started gaining major popularity and everybody was like, I want to use a real language. That's the only reason. I support Terraform using the CDK or AWS CDK also because of all the, it's just so much easier. I mean,
That makes sense.
Dev ops starts with dev. Let's use a language.
Yeah. I guess Janaka is agreeing over here.
100%.
Yep. I guess the second part is maybe not a question. It's like, would it be helpful to have this in the GitHub for community to discover this? So it's super cool. I guess everyone agrees to that. Cool.
This one, yeah. So we set that up. Paul set that up for the GDC to auto-replicate over to GitHub. We can do the same thing for this project.
That's awesome. And I guess we have this question about, is Auth0 mock your development? Never heard it before. Yeah.
Yes, that was created by myself and a coworker, Peter King. Yeah, we wanted to be able to do everything totally locally. And so, yeah, you can actually drop in the Auth0 libraries and into your UI, and it will work seamlessly with the mock in the GDC project. It's you know, it's not as fully featured as Auth0, but it'll log in and with the permissions that you've defined to let you use you know, an SPA or, you know, whatever JWT authentication.
So just as a feedback, I guess it would make a lot of sense for this Auth0 mock to be packaged as a local stack extension. Like we have this functionality where you can build out extension and basically run this as part of your local stack startup process. I guess Thomas can shed some more light onto that. I guess here's also a question.
Yes, I have a question. Thanks for the talk. It's very interesting. I was wondering about this DevNet idea that you have around having these, like treating sort of other containers as sort of sidecars to your sort of main container. I was thinking, like, at Localstack we have this problem of having a port range exposed that's you know, we spin up additional third-party services on, and I've been kind of thinking about having a way to be having this more dynamic rather than just telling users, okay, you need to have this static sort of port range, and you can't really change that at runtime. Like, do you have a solution for this, or do you have the same problem that you just have?
Yeah, because we run things in our CI pipelines, there could be multiple jobs spinning up GDCs running tests. And so we can't really expose ports to the host because there would be port conflicts everywhere. So we don't expose any ports to the host, and we use the DevNet so that all of the containers can talk amongst themselves and they can all listen on their respective ports. And we also have environment variables to use the pipeline job ID so that each container is unique as well, because otherwise you'll run into duplicate container names. And this sets up environment variables so that your tasks running inside the GDC can easily look up the various services it needs to connect to, and it's all internal on the internal DevNet. And so you can have multiple sets of GDCs all running in parallel, all talking amongst themselves in their own little container ecosystems, all separated on different DevNets. Gotcha.
Now, how do you get users to containerize their stuff that they maybe don't want to containerize? Because that seems the whole idea seems contingent on my, I don't know, Spring Boot application or whatever running inside a container in the DevNet.
Sorry, go ahead.
At the containerizing it isn't necessarily something that needs to be done. You bring up a GDC on top of the repository and you launch your Java application and it's running in the container. And then using that DevNet from another container, you can connect to that Spring Boot application. No changes needed by the developers. It's not like we're trying to containerize it to run in AWS necessarily. You know, it can any application can just be brought up in the the respective container, as long as it supports a containerized OS.
Gotcha.
So it shouldn't really require any additional work on the devs side, especially if they're not interested in containerization themselves.
All right.
Let me give you another good example of that. So we'll go to just like a directory that has a few SQL files in it and open up a GDC. The GDC has bundled with it all the SSM scripts for admins to get onto private resources in a target account, and all of our Bitwarden instrumentation makes it so in a command we can open up tunnels to completely private database clusters, and then you could run the SQL scripts against them. So the GDC gives us an environment. So that environment is the same environment for every single DevOps developer, whoever's doing that support across the whole company, across the whole globe.
All right, thanks for clarifying. Those are really neat ideas. I love it.
Yep. I guess since we're running out of time, we'll just take up one last question, and it's about like, what's the main advantage for you running this GDC script in comparison to writing a Docker Compose stack?
Well, the GDC itself, automates a lot of the complexities, and you can just fire it up and just run the script on your repository folder, and you're up and running. Obviously there's a lot of customization that can be done. So you're creating an env file, and things like that. But some of the other features of the GDC, like the Bitwarden automations and other workflow quality of life type things, make it a lot nicer to work in. And it does various other things too, like you can target a specific versions of various languages and things like that, or you can say, I always want the latest version of localstack or Pulumi or whatever, and it will actually go and check and see what the versions are for those and install them accordingly. Certainly you can hand roll quite a bit of things for for any stack, but the GDC just kind of aims to ease that and just make it really easy, especially for more complex things, like when you're running sidecar applications, and let's say you need to mount a folder from the host, but that folder, there's some overlap. The issue with that is you need to specify the absolute path. And the GDC sets up these environment variables so that you can map folders inside the container to the corresponding folders outside of the container, which is a massive headache, especially if you have repositories at different levels in the tree on the host. You run into a lot of nightmares trying to mount folders from the host inside the containers. Because the GDC also supports launching a second GDC from within the GDC. It doesn't run inside, it runs side by side, but it still needs to be aware of all the various paths to all the various sidecars so that they can all not just talk to each other on the DevNet, but also be able to mount those folders and share those resources. So it does a lot of the legwork to dynamically kind of figure out what all those paths are for you, which is just not possible in a straight YAML file.
Yeah.
That sounds
Awesome.
Perfect. Yep. Thanks a lot for sharing this. We won't be able to take up the rest of the questions because I want to present for a couple more minutes, basically just talk about LocalStack 2.1. And I'll just speed run through this whole thing just to introduce the kind of new features and the new enhancements that we have rolled out. So last week, we released out LocalStack 2.1. It is our first minor release after the LocalStack 2.0 major release. And this release has came up with a lot of exciting features that is further helping you to streamline your AWS development. So at first, we have DynamoDB. So a lot of the community members have been kind of complaining that DynamoDB has been pretty slow. And one of the reasons for that to happen was that the local stack's entire DynamoDB implementation is being powered by DynamoDB local. And we're actually downloading it from the AWS servers, which is pathetically slow to see at the best. So what we have done is we have basically added DynamoDB local to our Docker image itself. And what this will basically do is the users will simply experience a startup time improvement every time that they're using the DynamoDB APIs. So if you're having troubles with the DynamoDB service itself, please upgrade your image to localstack 2.1, and I guess you will be able to utilize much better performance. We have also made the CRUD operations 20% faster, so you will definitely get to see a spike on that. And apart from this, localstack now has started supporting structured access key IDs. And we have also taken up the multi-accounts to another level because we have introduced cross-account access. So now you can simply use Amazon resource names, basically ARNs, with your KMS keys, with your SQS queues, with your Lambda functions. And you can basically retrieve them even if they belong to some other account. For our licensed users, we have introduced massive enhancements to the IoT provider and AppSync. If you're using the IoT service on localstack, you will get to see that we are now basically supporting the registry events and the lifecycle events. And we also have this new IoT MQTT broker, which is now supporting MQTT v5. And just like AWS, it is also limiting the quality of service to 1. And you can also use the IoT topic rule engine so that you can send out the triggers to the DynamoDB tables itself. And finally, a lot of the users have been trying to use AppSync, and we realized that our AppSync implementation should be improved. And we have recently added support for AppSync JavaScript resolvers. So now you can basically process the logic within JavaScript itself. And for that purpose, we are using a Docker container with Node.js 16.x. And from the documentation side, we have made a lot of new enhancements to the developer hub itself. So if you navigate to the developer hub, you will simply find more and more new applications that are over here. So you will find some sample applications for SQS DynamoDB Fargate. You will find some other applications for step functions, for RDS initialization, and more of them. But apart from this, you will also get to see that we have this new filters feature. So what you can basically do is you can use these filters to navigate across this entire developer hub. And you can basically find applications that basically interest you out. For example, if you want to use SageMaker on your local machine, we have this one simple application that allows you to run an MNest handwritten digital recognition model completely on your local machine without having to connect to an AWS account. So please give this a run. Share us any feedback that you might have. And yep, I guess that pretty much sums the whole thing up. So we are open for another couple more minutes for the Q&A part. If there are no questions, we can call this a day. So thanks a lot, Janaka. Thanks a lot, Paul and Chad, for introducing a lot of nice stuff to us. I personally got to learn a lot, and I guess it gives me an impetus to start exploring these things out. So thanks again for being a part of this community event, and we hope you have a really nice rest of the day and rest of the week ahead. Yep.
Thanks for having me all.
Yeah.
Thank you.
Thanks for being here.
Yep.
Thank you very much.
Yep.
I had a question, Harsh.
Yep.
Does the machine learning application example work on a Mac M1, M2?
Yep, it definitely does. I have personally tested it. A few of my other team members have done the same, so it should work out. Unfortunately, yeah, the only thing is the Docker image that you need to pull is super heavy. So yeah.
That's okay.
Cool. Awesome. So I don't see any more questions that are coming up, so we can call this a day. So thanks a lot, everyone. And for anyone who missed the initial parts, you will find the recording on our YouTube channel itself. So stay tuned for the next community event. Bye, and have a great rest of the day.
Thank you.
Thanks for joining. Bye.
Bye.